Okay, real quick, couple things that'll help. So when you're sketching these polynomials, first of all, I want to remind you about something. Like if you want to know what the end behavior is, right? So what this is saying here is the limit of the function. This is saying as, all this stuff down here says, as x approaches infinity, what is the limit of f of x just means what is it approaching. So we're just filling in the blank. F of x approaches what? And that's what we're talking about there and there. Same thing, right? For all these questions, all you have to do, remember, is just look at the leading term. That's what dominates. Remember that day we looked at, a long time ago, we looked at what happened if we like zoomed out really far on a function? Yeah. Remember, and what we found was the only thing that really mattered was the leading term. When we zoom far enough out, the entire function is just completely dominated by the leading term, the polynomial, right? So that's all we have to think about. So as x approaches infinity, if I put a really big positive number in there, what's going to happen? Well, I'm going to get, if you look at this here, I know that because I'm taking it to a power, it's going to get infinitely big, right? So I already know it's going to be infinite, but the question is positive or negative, right? If I'm approaching positive infinity, well, a positive number to a large, positive number to the fourth is positive, but then if I multiply by a negative coefficient, it's going to become negative, isn't it, right? So I know because of this part right there, it's going to be negative, right? See what I'm saying? Another way to think about that would be, what would an x to the fourth function look like? If I were to graph y equals x to the fourth, if I graph an even function, remember what that looks like? Yeah, it's kind of like a modified, they all look kind of like polynomials, right? The end behavior is going to be, they're going to go out and up, out and up. So it's positive on both ends, right? But then if I multiply that by a negative, it's going to flip the whole thing around, right? So I know right away it's negative infinity. What about one like this? Okay, let's go down a little bit. What if I'm approaching, like let's do this guy. So what if I'm approaching negative, oops, where's negative? Got it. Okay, let's make this one negative infinity. Yep. I am recording. Yeah. So let's make that a negative infinity instead of an infinity. Right, so as I approach negative infinity, what did we just do? Well, now we took this, we have this positive, we have this fourth degree function, so it's an even function, so it's opening up. This time, a is positive, right? So it doesn't flip it over. So as I go to the left forever, as x approaches negative infinity, so that just means I'm going out to the left forever. We're answering the question, what's y? What's the function doing? It's going to go up to positive infinity, isn't it, right? And the other way to look at that would be, what if I just substituted in a really big negative number? If I take a really big negative number, like approaching infinity, but it's negative. But if I'm taking it to an even power, any negative number, doesn't matter how big, any negative number to an even power is positive or negative? Positive, right? So I'm going to get positive times positive is positive infinity, right? You see the pattern? Okay, what about like this guy here, how about? What if we're going to approach negative infinity, but now my leading term is odd. Okay, think what's happening there then. As x approaches negative infinity, f of x approaches what? Thank you. Sweet. That's for you whenever you get a chance.
Oh, yes. I think I lost it.
Okay, so how about this time? I'm putting in a really big negative number. A really big negative number to an odd power is positive or negative? Negative, right? Negative number to odd power is negative times a negative out front, positive, right? So once again, we know we're getting infinity because the number is huge and we're taking it to a power. But in this case, it ends up being positive because I've got a negative times a negative. If you look at what the power function behavior would be, what does x cubed look like?
A swoop down and up. Yeah.
Right? Opposite end behavior. So there's x cubed. Now if I multiply that by something negative, what's it gonna do? Flip it around, right? So when I go out to the left, it goes up forever. Okay? How about real quick, a problem like that? If I wanted to sketch that, what's gonna happen? Right? So if we made our x and y axes here, so what are my zeros gonna be? If I set this thing equal to 0,
0.
x equals 0, x equals 4, x equals -6, right? Okay, good. So we know we're gonna end up getting so these are gonna be my x-intercepts at 0, at +4, and at -6. The question is just what's happening in between, right? What's happening there? So we could do this, we can make a table, and that's what I would encourage you to do, but we could even kind of think our way through this one without. If I were to multiply this whole thing out, I don't want to do it, but if I were to multiply the whole thing out, I want you just to tell me what the leading term would be. If I multiplied the whole thing out, what's going to be, if I square out x plus 6, I'm going to get, would you agree I'm going to get x squared plus some junk? Right? So if I distribute that to the x, I'm going to get an x cubed plus a whole bunch of junk. If I distribute that x through, aren't I, if you look at what this expanded thing would be, and we don't want to do it, it'd be a lot of work, but wouldn't it just be x to the 4th plus a bunch of other stuff we don't care about? Right?
Yeah.
So we can see that we would get x to the 4th plus, who knows, right? So if we're going to get x to the 4th plus a bunch of stuff, what's the end behavior of this function going to be? If I go clear out to the right and clear out to the left,
Positive.
it's going to behave like x to the 4th. Now, in here, it's going to move around and do a bunch of weird things when we get close to home, close to the origin. But if I go way out to the left or way out to the right, isn't it just going to be that? Right? So we know then that if we're graphing this thing, out here at the ends, it's got to go up to infinity and up to infinity, right? Now let's look at the nature of each of these zeros. This is a linear 0, right? It's taken to the first power. So is that the kind of 0 that's going to cut through like a line or bounce like a quadratic?
Bounce.
Is it taken to a power? Remember this stuff? Right? If it's taken to the first power, it's just cutting right through the x-axis, right? So this is one right here where we know it's going to be cutting through, going straight through the x-axis, right? So if we know it has to go up to the left, then doesn't that mean it's doing something like that?
Yep.
Okay, how about at 0? That's also taken to the first power, right? So we know that's one where it's going to be cutting straight through, so it's got to be doing something like that,
Yep.
right? Now, what about this one, though? Look here.
Where-
This one, that one is squared. It's got a multiplicity of 2. So the 0 at -6, that's not going to cut through. What's it going to do? It's going to bounce, right? So this one we know is going to have to do that, right? So the function, that's our function, isn't it? Right? Now, we can, so you can just think your way through this and take some shortcuts. You don't have to, right? You could just as easily make the table that I showed you guys how to do. Right? If we've got x's and y's, we can just put in all the values. We knew we had a 0 at -6, we had a 0 at 0, and we had a 0 at 4. And we could just pick some random values in between, like 2, -2, -10, +10, and just see what the sign of the function is. What are we going to find? If I plug those into my function, aren't I going to find that it's positive there, it's positive there, it's negative there, and it's positive there? That also would tell us what this thing is doing, right? Okay, that make sense? Okay. So what's the difference between that one and this one? This one you just have to, I only gave you one like this, but this is one where you just have to go through the process of finding the zeros. Okay, but I will, what's our only option on this? It's got five terms.
Grouping.
We can't group it, it doesn't have four, right? Grouping works for four, that's a way we can factor a polynomial with four terms. With three terms, we can use the quadratic trinomial trick, right? Magic numbers.
Yeah.
Two terms, we gotta use, sum or difference of cubes, sum of squares, difference of squares, that kind of stuff, right? Our binomial patterns. But it's got five, so what's our only way of doing this one?
Oh, yeah.
Okay, so, right, we gotta use the rational root theorem, right? We've gotta find a value that we can divide into this synthetically, and we get that from factors of the constant divided by factors of the leading coefficient, right? Well, that's just a 1 out in front of -1, so we know we're getting integers on the bottom, that's good news. So we would have to just check all the values, our possible zeros for this one. Would just be plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Now I built all these, so you're gonna get, it's gonna work out, so you're gonna get easy, you're gonna have to just go through that list, starting at the easy ones, but you're gonna get enough of those that are gonna make this thing. They're not gonna be that hard, right? Once you find one of these that works, then it's gonna bump this down from a 4th degree to a 3rd degree, so it'd be a 4 term at the most, and so then you probably can even maybe factor by grouping, okay? You get the idea? Okay, I don't wanna take too much of your time, does that get you going? All the rest of these are, oh, and then there's one like this, what about this one? One more. Yeah, that's good. So what do we know about this one? If I wanna build the simplest possible polynomial from this, the trick here is just what kind of what's gonna be the factor that goes with that 0? X plus 7. Okay, so how about the one that goes with this one?
X plus 3 squared.
X plus 3, and because it's bouncing, right? Because it's bouncing, we gotta make it squared. How about this one? X minus 6, and once again, because it's bouncing, it's squared. And then we gotta ask ourselves, do we need a positive 1 or a negative 1 out front? So it tells us the leading coefficient will make it positive 1 or negative 1. Well, if I go to the right, it's going up, right? It hasn't been flipped. Odd functions, if it's an odd power of x, remember like x cubed, for example, or x to the 5th, they always go up to the right and down to the left, right? That's what this one does. Okay, so it's fine. If it's an even leading term, they both go up normally. They'd get flipped if it was negative. But does it make sense that because this side is going up and this side is going down, that that's going to be a positive odd power? So a positive odd power function, we call it. In other words, A is 1. We don't need to put a negative sign out. So that's our answer, right? And then these are the easiest one of the bunch probably. All you're doing here is you're just saying, based on its degree, well, if I multiplied this out, if I expanded it out, what would the leading term be? I'm going to get negative 2 times 3, so I'm going to get a negative 6. And what would my power of x be in the leading term? Be 4. Right, I'm going to have an x squared times an x squared. Everybody see that? And I don't even really need to know that that's a 6. I just need to know I'm going to get a negative number out front from an x to the 4th, right? So based on the degree, what's the most possible x-intercepts it could have?
4.
4. It's a 4th degree polynomial. So based on that degree, what's the biggest number of turning points it could have? Say it again. 3. Yeah, 1 less than that, right? Okay. As x approaches negative infinity, what's going to happen? Well, I'm going to get a negative number to an even power is positive times negative. It's negative infinity, right? As I approach positive infinity, I'm going to get positive to the 4th is positive times negative is negative. Okay? Make sense? Okay, go. If you have questions, bring them up. You can test if you want to. Okay. Oh.
What are you hooing about?